This is our wireless outdoor thermometer. It receives temperature from the transmitter that is outside in the garden. Display is similar to the clock that we described recently. It is a LED matrix built from 7 independent LED addressable strips that are connected to 7 Arduino pins. As you can see, the row second from the bottom has a little bit of a problem. I'm not sure exactly what is going on here, but I think there is probably an error somewhere here along this strip. Now, and that's the whole purpose of building this on the 7 independent rows or 7 independent strips, because otherwise, if this happened, if this was just one continuous strip, which is possible, then also this row below would be completely messed up. Whereas here we have only one row that is a problem. I need to look into it and see what exactly is going on. Is it the connection in the strip? I think that's a connection in the strip that is that's causing this this problem. There's much less knobs than described in our clock in the previous video. There's just one encoder here, and that is for adjusting the brightness. So if we go all the way down, that's the minimum brightness that we can achieve, and then we go maximum brightness, and that's the maximum brightness that we can have on the displays. Colors do change depending on the temperature, so it all depends on what's the outside temperature, then we'll have different colors. And also these icons here change from the dry weather to there is an umbrella if there is rain outside, if this rain sensor gets wet, obviously plus minus. This is the transmitter for the temperature. It's very windy today, so you probably hear lots of noise. But I thought I'm going to just show you how it looks like. So this is the wall socket, and basically there is a 5-volt adapter that gives power to the Arduino board inside there, behind this, inside this enclosure. So you can see Arduino Nano sitting there, and then there is a transmitter. Because transmitter needs 3.3 volts, we have a conversion board just underneath the transmitter, and then there is also a 3.3 voltage converter sitting under the board, just to make sure that the transmitter has enough power. Here you can see the temperature sensor sitting here, and then another sensor is just this rain sensor. It's basically a copper board with the traces, and they get shorted when the rain is falling. And that's how it looks like inside. It's open for ventilation. Here is an antenna. A dipole is adjusted for the correct frequency, so the length of the antenna is adjusted to give a maximum transmission power, and here you can see the rain sensor sits underneath, and the rest is here on the board, and that's basically what we've got in here. This encoder, so like apart from adjusting brightness, the push button should give us a signal strength and should give us also a battery status. It's prepared for for being powered by the battery. Obviously right now it is meaningless because it's being powered from the wall. At the back we have very similar arrangement. So there are two boards. This board is much shorter. There is again 5 amps, 5 volt power supply. We have Arduino board. That is here Arduino Nano sitting here. Very similar to the transmitter, we have a wireless receiver module sitting on top of the voltage and logic voltage converter, and there is a 3.3 volt power supply underneath. And here we've got 7 lines going into from Arduino into the LED strips. Here is an encoder, and here is again dipole antenna adjusted to 868 megahertz frequency that we use for wireless transmission, low power wireless transmission, and that's essentially all. The hardware arrangement of the thermometer. There are 2 separate circuits. There is a receiver with LED matrix display. So essentially we have 7 LED strips. They are independent strips. Each strip is supplied directly from the PSU with 5 volts and ground, and that's direct from PSU, and on top of that there is a data lines, so 7 times data lines that are connected to D9 to D3, and they're connected to the Arduino through 330 ohm resistor. So there is basically Arduino going into the resistor and then directly into the these LED strips. Okay. Then obviously we have Arduino sitting in the center of it. So in our case it's Arduino Nano. And then we have a receiver. So the receiver is 8 megahertz, 868 megahertz RFM69HW module, and it is an SPI line. So what we need to connect to that from the Arduino is MISO line, MOSI line, clock line, and there is also D1
output required for the library to work. The RFM69 is a 3.3 volt module. So what I've done, I put a separate voltage controller .3 volts. It's a popular 1117 IC that provides a separate clean power supply to the RFM69, and then there is also a logic converter . 5 volts that Arduino uses to 3.3 volts that RFM69HW uses. So there is a bidirectional logic converter, and I use TXS0108E converter. So essentially this is what we can find, and then obviously there is a PSU, again 5 volts, 5 amps. I use 5.6 amps because that's what I could buy 240 volts switching power supply, and that's the receiver. The radio module, radio transceiver. There is also custom made dipole antenna tuned to 868 megahertz. So that's where the antenna connector goes to for on the RFM69, and that's what's on the shelf inside the house. Temperature transmitter that sits in the garden is run again on Arduino Nano. This is, in ideal world, this should be connected to the battery and the solar panel. So that's the ultimate and this is solar power panel that I was hoping to use together with this power bank to provide power independent from being connected to the main circuit. It is being tested. I think this panel is not enough actually to power. The second problem is the power bank can either be charged or provide power. I think the Arduino is clearly unhappy when the solar panel is charging the power bank. So it is still a little bit of a work in progress, and we'll see whether we can get it to work. That's the ultimate idea behind it, but at the moment it's run from the PSU, from the wall. Then what is connected to the Arduino is obviously the transmitter receiver. So again, x868 megahertz version of RFM69HW, again SPI, so it's going to be exactly the same lines like for every SPI line connected to Arduino, D12, D13, D12, D11, and then we have D1 connected also there. And another thing that we have hardware-wise is obviously temperature sensor. Temperature sensor is I2C, and the model used is, if I remember correctly, BMP 280. We use only temperature. It's also capable of registering pressure, but we use only temperature for our purposes. Now there is a little bit of a question mark over the power supply or voltage supply for the BMP 280. Specification apparently says no more than 4.5 volts. In this case we run it from 5 volts and ground, and obviously SCL and SDA, and that's what is connected to the Arduino. So A4, A5, 5 volts and ground, so it's connected directly to Arduino, but potentially it should be connected to the logic converter. So 5 volts bidirectional to 3.3 volts. And that's again TXS 0108E. It's not on temperature sensor, but like in the receiver, the RFM69HW needs logic converter. This is exactly the same custom-made dipole antenna tuned to 868 megahertz. So that's logic converter, and I use again voltage controller. Uh, 3.3 volts, again 1117 type of IC to provide power to the logic converter and RFM69. So whether temperature sensor also needs to be connected to this logic converter voltage controller is a little bit of a question mark. I've done it on the 5 volts lines, data lines and power supply. But I think according to specification it should be running through the logic converter and 3.3 volts. And finally we have rain sensor that is connected to one of the analog inputs. I'm not sure whether it's A0, but that's basically where it goes. One of the analog inputs. This is a very simple device. There is a operational amplifier connected to the 2 trucks, copper trucks. When the rain falls, it reduces the resistance between the trucks. There's a connection, electrical connection between 2 trucks, and then we can adjust the sensitivity by changing the operational amplifier output. So that's how this rain sensor works. Very simple circuit, many of them available online. and that's transmitter. So quite simple, again, simple hardware built from the modules, easily available online. Apart from the LED displays that we use both for clock and for this temperature display, everything else is basically available in the online shops for a relatively small amount of money.